Now in these curves, what we want to do is take a rotation this time, but instead of rotating around an axis, we want to rotate around a line. So, and the one we want to rotate, the first one, is taking the curve y is equal to x squared and rotating around the line y is equal to 1. So with this one, what we want to do is firstly notice where our thickness is going to be. So because we're rotating around y is equal to x is equal to, x is equal to 1, our thickness is going to be delta y. So we're going to end up integrating with respect to y. What we then want to be able to do is get our area of our cylindrical disc. Now, when we do that, we're looking at trying to get the radius of this disc, which is not as easy as it seems this time. It's not just a straight pi y squared. So what we look at, the radius here is given to us by looking at the idea that the distance from the line, from the center of the circle, to the axis would be 1, and from the edge of the disc to the axis would be x. So the difference there would be 1 minus x, which is going to be our radius. Our radius is our difference there between 1 and x. So that starts to become our radius. Because we're going to be integrating with respect to y, we want our function in terms of y. So x starts to be written in terms of y as well. And we can see why we do that, because if our cross section is 1 plus 1 minus x, our area becomes pi times 1 minus x. So the radius there gets used, and then the pi r squared, pi times the radius squared times the height, and our height is delta y, and the 1 minus x is our radius. Then our radius needs to be in terms of y, not in terms of x. So we can go and then put it into the integral between 0 and 1 and integrate. So what we're doing is doing that substitution. The easy way to do this integration is just to expand it out and then integrate our function. So we look at the next one. This time again, we're rotating around x is equal to 2. So our thickness is going to be delta y. Our function is 4 minus x squared. So this time our radius of our disk is going to be the 2 minus the distance x across there, so 2 minus x. So there's our radius. We do our manipulation of y is equal to 4 minus x squared. So x squared equals 4 minus y, or x is equal to square root of 4 minus y. And we see we need to do that when we get our cross section of 2 minus x, our area of pi 2 minus x squared, all squared, which means x, the volume is in terms of delta y. Our height there, we need to get our x in terms of y to get our function. So there's what we need to do there again. So we getting that expansion again, that's the easy way to do it, and then getting through to get our integral. So the integration, still not too hard in that respect, but it's getting that, getting their thickness and getting the radius. So this time we're rotating around y is equal to 4. So it's similar to what we did in the x-axis. So this time our thickness is delta x. Again, to get our cylindrical disc, our radius was 4 to the center of the disc and y to the edge of the disc. So the idea there would be that we get our radius as 4 minus y. So that would work out as our radius. So our cross section is 4 minus, gives us a radius of 4 minus y. So our area would be pi times 4 minus y all squared. Now to get 4 minus y in terms of x, well, if y is equal to 4 minus x squared, this becomes 4 minus x squared, which the 4 minus 4 cancels, gives us x, just x squared. So what starts to look rather complicated, it starts to come down very nicely. Gives us an area of pi x to the power of 4, volume is pi x to the power of 4 delta x, and then we integrate that to get our answer through. So we can start to see that the hard part's not necessarily the integration. Hopefully that's becoming quite clear. It's making sure we get that correct radius and the correct thickness of our disk, so we can then do our manipulations to get our correct formula to be able to put it into the integral, into the integration to be able to get our volume.